today's topic is Bohr's model of atom. Bohr's model of atom, उससे पहले आते हैं Thomson's model of atom, Rutherford model of atom that you have covered in class 10th, right? And it is eliminated from the class 11 syllabus. बोर्स मॉडल ऑफ एटम. तो बोर मॉडल ऑफ एटम जो है वो फर्स्ट अटेम्प्ट था जो कि मॉडर्न टाइप का, ठीक है. उसमें बहुत सारी चीजें कवर की, बट उसकी जो मेन पॉइंट था, इट इज फॉर वन इलेक्ट्रॉन सिस्टम. वन इलेक्ट्रॉन सिस्टम के लिए ही वो एप्लीकेबल था. सक्सेसफुली एक्सप्लेन किया उसने, बट उसकी जो मेन पॉइंट था वो वन इलेक्ट्रॉन के लिए, वन इलेक्ट्रॉन वाले जैसे हाइड्रोजन एटम या बेरिलियम हाइड्रोजन एटम, या अगर हीलियम हो तो हीलियम के लिए नहीं होगा, हीलियम प्लस, लिथियम 2 प्लस, बेरिलियम 3 प्लस, बोरॉन 4 प्लस, इनके लिए एप्लीकेबल था. इलेक्ट्रॉन इज revolving around the nucleus. क्या उसने बोला कि इलेक्ट्रॉन जो है they are revolving around the nucleus in circular paths. These are actually well defined पाथ्स है. तो सर्कुलर पाथ्स, वो सर्कुलर पाथ्स क्या है, वेल डिफाइंड. ऐसा नहीं कि कोई भी सर्कल खींच दिया और वो बन गया पाथ, ठीक है. दीज आर वेल डिफाइंड, ठीक है. एंड एनर्जी, वेल डिफाइंड पाथ्स having fixed radius and energy. उनकी फिक्स्ड क्या थी, रेडियस एंड एनर्जी. These paths are called एनर्जी लेवल्स. क्या बोला उनको, एनर्जी लेवल्स. और ऑर्बिट्स और शेल्स. बट ये जो ऑर्बिट्स है नाम, ये तो पहले भी देख चुका था रदरफोर्ड, ठीक है. तो उसने बोला है दीज आर कॉल्ड स्टेशनरी स्टेट्स. क्या बोला उसने उसको, उनको उसने नाम दिया स्टेशनरी स्टेट्स. स्टेशनरी स्टेट से क्या मतलब था उसका, कि जब तक वो इलेक्ट्रॉन एक ही ऑर्बिट में घूमता रहेगा, मतलब ये न्यूक्लियस है, राइट. ये फर्स्ट ऑर्बिट, second orbit, third orbit, and so on. First orbit, second orbit, third orbit, fourth orbit, ठीक है. तो ये जो पाथ्स हैं सर्कुलर है, एलिप्टिकल सा लग रहा है, बट दे आर सर्कुलर पाथ्स. तो when electron is revolving in these orbits या shells या energy levels या stationary states, its energy remains same. As long as it is revolving in the same shell, its energy remains stable. इसलिए उसको बोला उसने, they are called stationary states. कि इलेक्ट्रॉन के मूव करने से उसकी एनर्जी पे, टोटल एनर्जी पे कोई फर्क नहीं आएगा। मान लिया इसकी एनर्जी है E1, तो इट रिमेन्स E1, दो इलेक्ट्रॉन्स आर इवॉल्विंग, इसकी एनर्जी मान लिया E2, E3, E4, सो एनर्जी रिमेन्स फिक्स्ड। ये फर्स्ट पॉइंट का अगर क्वेश्चन पूछे कोई कि व्हाई दीज एनर्जी लेवल्स आर कॉल्ड स्टेशनरी स्टेट्स, तो आंसर लिख सकते हो आप। ओके, पॉइंट नंबर 2, द एनर्जी जो है ऑफ द एनर्जी ऑफ एन इलेक्ट्रॉन in its orbit does not change with time। सेम बात वही होगी ना कि स्टेशनरी स्टेट है वो, इसलिए उसकी एनर्जी है इलेक्ट्रॉन की इन इट्स ऑर्बिट, फर्स्ट ऑर्बिट, सेकंड ऑर्बिट, थर्ड ऑर्बिट, फोर्थ ऑर्बिट, तो एनर्जी जो है इलेक्ट्रॉन की इन दैट पर्टिकुलर ऑर्बिट डज नॉट चेंज विद टाइम, इट रिमेन्स फिक्स्ड। ठीक है, ये सेकंड पॉइंट हो गया। नाउ थर्ड, when a certain amount of energy is absorbed by the electron, then क्या होगा? अगर ये एनर्जी एब्जॉर्ब कर लेगा एक पर्टिकुलर अमाउंट की एनर्जी, कितनी? डिफरेंस बिटवीन द टू एनर्जी लेवल्स, कम से कम इतनी एनर्जी। ऐसा नहीं हो कि ये इसने एनर्जी एब्जॉर्ब की और यहां तक पहुंचे, यहां तक, जब तक वो यहां तक नहीं पहुंचेगा तब तक वो एनर्जी वो एब्जॉर्ब ही नहीं करेगा। देखो ये फैक्ट देख लो, हम क्या सोचते हैं कि थोड़ी थोड़ी एनर्जी लेता रहेगा, थोड़ा थोड़ा जाता रहेगा, जाता रहेगा, जाता रहेगा और यहाँ पहुंच जाएगा कभी ना कभी। ऐसा नहीं, वो एनर्जी कब एब्जॉर्ब करेगा? जब उस पे जो एनर्जी फॉल करेगी, जो फोटोन बताया ना, वो फोटोन फॉल करेगा तो वो इतनी एनर्जी दे दे कि इस एनर्जी डिफरेंस के बराबर, या इस एनर्जी डिफरेंस के बराबर, या इस एनर्जी डिफरेंस के बराबर, तभी वो एब्जॉर्ब करेगा। इसलिए लिखा है when a certain amount of energy is absorbed by the electron, then it jumps from lower orbit to, या lower energy level to higher एनर्जी लेवल, लोअर एनर्जी लेवल से हायर एनर्जी लेवल पे वो शिफ्ट कर जाएगा, एंड वाइस वर्सा। वाइस वर्सा मीन्स कि जितनी एनर्जी उसको शिफ्ट करने के लिए चाहिए ऊपर, मान लिया 1 से 2 में गया, एनर्जी एब्जॉर्ब की, सो 1 से 2 में चला गया। ठीक है, अब अगर वो 2 से 1 में आएगा तो उतनी ही एनर्जी क्या करेगा? रिलीज। तो अगर सर्टेन अमाउंट ऑफ एनर्जी इज रिलीज्ड बाय द इलेक्ट्रॉन, देन इट फॉल, जंप्स की जगह हो जाएगा फॉल्स फ्रॉम हायर लेवल टू लोअर लेवल। ठीक है, एंड एनर्जी एब्जॉर्ब्ड इज इक्वल टू एनर्जी डिफरेंस बिटवीन द टू लेवल्स, टू एनर्जी लेवल्स। ठीक है, तो ये नोट कर लिया ना। मैथमेटिकली तो पहले लिख लो कि एनर्जी एब्सॉर्ब्ड बाय द इलेक्ट्रॉन is equal to energy difference between two energy levels. Energy difference between two energy levels. That is, if E1 is energy of lower shell and E2 is energy of higher shell, ठीक है. एनर्जी एब्सॉर्ब्ड अगर हम डिनोट करें इसको डेल्टा ई, and mathematically delta E is equal to E2 minus E1, right? That means if electron jump from lower level to higher level, then energy absorbed is equal to energy difference between the two levels, मतलब E2 minus E1. See, ये जो अपने एनर्जी लिखा है डेल्टा E इक्वल टू E2 minus E1, it is related to a particular frequency according to Planck's equation. E equal to h nu. It is related to a particular wavelength, nu equal to c over lambda. It is related to particular wave number. Okay, this is delta U. Change in energy absorbed in case electron jumps from lower level to higher level, and this is also the energy difference, energy when energy released when electron falls from higher level to lower level. कितना कौन सा पॉइंट हुआ ये? पॉइंट नंबर थर्ड. Okay, then fourth, the energy levels, the different energy levels, different, ठीक है ना, different are represented as K, L, M, N for n equal to 1, 2, 3, 4 respectively. That is, K shell means first shell, L shell means n equal to 2, M shell n equal to 3, N shell n equal to 4, K, L, M, N. Right? Now, point number 4. That is very, very important. Because only those orbits are permitted in which angular momentum of the electron is integral multiple of h upon 2 pi. Very, very important. Only those orbits are permitted in which angular momentum of electron is equal to integral multiple of h upon 2 पाई। बहुत ही इंपॉर्टेंट पॉइंट है ये। एंगुलर मोमेंटम का फॉर्मूला क्या होता है? यस, एंगुलर मोमेंटम इज mvr. Angular momentum is equal to m. Linear momentum is m into v, and angular momentum is m into v into r, and that is equal to integral multiple of h upon 2 pi, where n is 1, 2, 3, 4, so right, and m is mass of electron, v is tangential velocity, means linear velocity of electron, r is radius of orbit. Okay, so mvr equal to nh upon 2 pi, and what is h? What is h? H is Planck's constant, and its value is 6.626 into 10 raised to power minus 34 joule second. Okay, and that you know, h value is this, mass of electron you know, velocity depends on the n shell number, radius also depends upon shell number, that we will sort out. Okay, तो ये हो गए अपने 5 points. Now sixth one, actually now we talk about energy. सबसे पहला पॉइंट क्या किया था कि इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड द न्यूक्लियस इन वेरी डिफाइंड पाथ्स, सर्कुलर पाथ्स, वेरी डिफाइंड सर्कुलर पाथ्स हैविंग फिक्स्ड एनर्जी एंड रेडियस। रेडियस भी फिक्स है और एनर्जी भी फिक्स है, और ये एनर्जी और रेडियस किस पे डिपेंड करता है? एंड पे। ठीक है, तो वो हम एनर्जी के लिए अब डिराइव करेंगे। सो द मोस्ट इंपॉर्टेंट प्रॉपर्टी इज द एनर्जी ऑफ stationary state, energy of the stationary state. ठीक है, and that energy is equal to minus RH, I will write it as Z square N square. Actually Z is 1 for hydrogen atom, but I am extending it to hydrogen like atoms. See, for in general it is written as minus RH into 1 upon N square, because Z is 1, but Z is 1 only for hydrogen atom, but these are called hydrogen like atoms. These are hydrogen like atoms. For them, see, Z is 1, helium plus Z is 2, for lithium 2 plus, Z is 3. For beryllium 3 plus, Z is 4. For boron, Z is 5. Right? So better to write like this. This is general, right? And RH is called Rydberg constant. Very important point. Rydberg constant, and its value is 2.18 into 10 raised per minus 18 joule. Its value in joules is 2.18 into 10 raised per minus 18. Okay? And then what is Z? Atomic number of species. Why I write species? Because these are hydrogen like atoms. Okay? Then and shell number 1, 2, 3, K shell, L shell. We have written K, L, M, and then O. Okay? And 1, 2, 3, and 4. Now, the point that this is the energy which is fixed, so that means energy is absorbed or released, not continuously but discontinuously in the form of bundles, packets, and those are called quantum. So he used first time the quantum theory, Planck's quantum theory. Bohr's model used Planck's quantum theory first time, because he said that orbits are, shells are, energy levels are, stationary states are quantized. Okay? So energy is, as energy is fixed, so energy is absorbed or emitted or released, not continuously but discontinuously in the form of packets called quantum or photon in case of light. Photon in case of light. This means electron cannot move continuously. Move means not like this circular path. Cannot move from one level to another level. Cannot move continuously, but can jump. But can jump. Okay? From one energy level to another energy levels. The energy of the electron is in the same way as that of angular momentum. से आपने दो इक्वेशन लिखी. फर्स्ट इज mvr equal to nh upon 2 pi. See, angular momentum is integral multiple of h upon 2 pi. You know h is constant, 2 pi is also constant. So it is 1 time, 2 time, 3 time, 4 time depending on n. Same is the case here. Energy that is equal to minus RH z square over n square. For particular atom, z is fixed. For particular shell, n is fixed. RH is constant, but as n varies, energy varies. So energy of the nth orbit depends on n. As n changes, energy changes, but in quantized way. It is not increasing continuously. Now, let me tell you what it signifies. See, Z is positive, it is atomic number, N is 1, 2, 3 positive, RH is, you see the value 2.18 into 10 raised per minus 18 joule, that is also fixed, that is joule per atom. Keep in mind, RH is, that is joule per atom. Okay? So what it means? Negative means as En equal to minus RH z square n square. This means electronic energy is always negative. Means electronic energy is always negative. समझ में आया? Energy of the electron in an atom is always negative. बहुत important चीज है. If question is there कि what is the energy of an atom, energy of an electron in an atom, so that is always negative. So what this negative signifies? See, this is nucleus. And so on, n equal to 1, 2, 3, 4, so on, n equal to infinity. One more thing. How many shells are possible in an atom? Tell me. How many shells are possible in an atom? For all beta, stationary position, there are no stationary position. These are stationary states. Stationary states means energy of the electron remains same when it is in the particular shell. Means it cannot jump from one shell to another, or it cannot fall from one shell to another. As soon as it is traveling, it is moving in the same shell, its energy remains constant. That means that's why term stationary is used. This is first time told by Bohr, because Rutherford failed to explain that when a charged body is moving around another charged body, oppositely charged body, then why this electron cannot lose energy? तो इसने खत्म ही कर दिया काम कि when electron is revolving in the same shell, as long as it is in the same shell, its energy remains same. It is fixed. That's why that is called stationary state. First stationary state, second stationary state, third. But wherever it is, its energy is negative. Why is it so? See, when we put n infinity, what is the value of energy? Tell me. What is the value of energy if I put n infinity? Then it is inverse. When n is infinity, energy is 0. That is defined. First of all, how many shells are possible? Infinite. For a particular atom, how many shells? For a particular electron in an atom, how many shells are possible? Infinite. Right? That is the first answer. Second, energy of the electron at infinite shell is 0. Energy of the electron at infinity. Infinity means it is completely removed from the atom. That is called free electron. When we provide such amount of energy, huge amount of energy, that it is free from the attraction of the nucleus. न्यूक्लियस का अट्रैक्शन जैसे जैसे दूर जाएंगे, न्यूक्लियस का अट्रैक्शन क्या हो जाता है? कम. कोई भी चीज हमसे दूर जाएगी तो उसका हमारे लिए अट्रैक्शन क्या होता जाएगा? डिक्रीज. सेम इज द केस विद एटम. When electron is moving away from the nucleus, then attraction of the electron towards the nucleus, or we can say attraction of the nucleus towards the electron decreases. So it goes on decreasing. So at infinite, there is no attraction between the nucleus and the electron, and that is called free electron. So for a free electron, its energy is supposed to be 0. It is not 0. It is supposed to be 0. As it is supposed to be 0, so when it comes in attraction with the nucleus, so when they attract any two particle, any two charges, opposite charges, when they attract each other, what would happen? They release energy or they absorb energy. Energy is released. Okay? So that is the theory behind it. Okay? For an electron at infinity, energy of electron is supposed to be एक इसका आंसर लिख रहा हूं मैं. इफ क्वेश्चन इज व्हाई इलेक्ट्रॉनिक एनर्जी इज ऑलवेज नेगेटिव, तो यू स्टार्ट विद कि फॉर इलेक्ट्रॉन एट इंफिनिटी एनर्जी ऑफ इलेक्ट्रॉन इज सपोज टू बी 0. नो, when it is when this electron is in attraction with nucleus of an atom, means when this electron is in the atom, then it releases energy. So its energy becomes less than 0, because we suppose its energy to be 0 at infinity. So when it comes in connection with the nucleus, its energy is released. So energy is released from 0, so its energy becomes less than 0. So electronic electronic energy is always negative, right? So that's why electronic energy is always negative, because its energy at infinity is supposed to be 0. So when it comes in contact with the nucleus, when electron is in the atom, obviously when electron is in the atom, it is in attraction with the nucleus. So due to the attraction, energy is released. That's why electronic energy is less than 0. Say this is the relation RH Z square over N square, right? So when it goes up, then its energy becomes less negative. But it is negative. It becomes less negative because maximum value is 0. Keep in mind, maximum value is 0, right? So you can write point number. How many points we have written? कितने points लिखे थे बेटा? I think we have written points 6. ठीक है? So you can write 7 point कि as n increases, energy of the electron increases. Means its energy becomes less negative. It becomes less negative, right? That means E1 is less than E2, E2 is less than E3, E4, E5, so on. Okay? Next point is, as n increases, energy difference between two energy levels decreases. That is also very important point. Means E2 minus E1 is greater than E3 minus E2, which in turn greater than E4 minus E3, greater than E5 minus E3, and so on. As n increases, energy difference between the two energy levels decreases. First level at this point, second level, third level, fourth level, fifth level, means as we go up, energy difference between the two levels goes on decreasing, and at the end it becomes continuum. Continuum means बिल्कुल energy difference minor हो ही ना. This is E1, E2. See, energy difference is huge, but E2, E3 it becomes less. E3, E4 still less. E5, E6, and so on. See, energies are increasing. Energy is increasing, but energy difference is decreasing. Okay? Time. So let's see. In a hydrogen atom, an electron jumps from third orbit to the first orbit. So you know, what is the energy first? Energy is equal to energy released actually. In this case, energy is released. So energy released is equal to E3 minus E1. E3 minus E1, because higher to lower, higher minus lower. Okay, so and this is minus RH, because it is hydrogen atom, so Z is 1, and third level means 1 upon 3 square minus RH into 1 upon 1 square, 1 square, 1 square, right? Z is 1 and here 3, 1. Okay, so it is minus RH, take it as common, sorry, take RH as common. Okay, so it becomes 1 upon 9 minus 1, it is minus plus, so it becomes 1 minus 1 upon 9, right? This become R minus plus, so RH is common, so it is 1 and this is 1 upon 9, so it becomes RH into 8 upon 9. And what is the value of RH? RH is 2.18 into 10 raised power minus 18 joule. So just put the value and get answer in joules. Then you know energy is equal to H nu. So what is nu? Delta E over H. Delta E, you have H, you know what is H? 6.626 into 10 raised power minus 34 joule second. That's it. Right? So just solve it and send me answer.